everyone. It's a privilege to be here at Helvetic Ruby in beautiful Geneva. Today, I'm excited to share about a story about turning a really local development challenge into something global, and it involves one of my furry friends who we'll be meeting really soon. And the core idea is how a small idea can make a global impact. So it's something very easy to understand and not very technical, I believe. So first, we're going to meet the brains behind this idea, who made this operation possible. So I would like to make him meet my dog. He helped me contribute to Ruby by giving me some basic ideas of his daily life and a touch of humor, of his personal insights of who he meets and what sort of food he eats. And I got really good insights. So I thought, why not use him as our co-presenter today? But before we begin, so the point here is Oliver, the dog's name, and his friends are all data-driven, which means he has his favorite food, and he would like to make a spreadsheet for logging his favorite food. But his preferred method is not CSV, like most of us. So this is where sort of our adventure begins. Just think of it like every good story starts with a problem to solve. So here we have a list of him and his buddies, his friends. And it's just a basic example of how CSVs and TSVs work for those of the audience who have no clue what it is. So what you see on the top, it's called comma separated value. You see there's comma between the fields, and which works well, but let's say instead of the commas, I would like to use the tabs. And that's where it becomes a bit problematic. So before we go into the big problem, I'm just trying to help everybody understand what is CSVs and TSVs. So the key difference is just one character. We're using the comma versus the tab. But this small difference makes a huge practical impact. Because if you see here, the information is same, but the way it's delimited is different from each other. So Oliver came to me the other day and he said all of his friends use CSV, but in Oliver's word, he wants to use TSVs. So this is where the core issue was, because he showed me, as you see, we have bacon, cheese, and liver. There's a fundamental issue because in the bacon, cheese, and liver, the single entity is being broken by commas because it's not treated as a tab. So this shows the real-world impact. He cannot share his data, there's no collaboration happening, and it's just not an inconvenience, but it creates a barrier to sharing information. So let's look at the specific data that's causing the problem to begin with. So we look at the problematic CSV data. So if you look at the bacon and cheese on the second line, and if you notice on the liver and onion on the third, if you count the columns, you would expect 3, but the parser will see 5 because of the internal commas. And this is a very classical CSV parsing problem, and there's not so much of concrete solutions to it. So he's frustrated about it. And this could be a feeling many of the developers might share with the data format limitations. So here's where the story turns, since every problem contains the seed of its solution. What if we just use tabs instead of commas? Because we can just use the, instead of the commas, we just use the tab for the text descriptions, which means we don't have to specify the column separator every single time. This works, but it's not very convenient to use in the long run. And this could also be shared as the developer experience pain point, because we might have a moment where we think there might be a better way to do this. So this was the moment where we think there should be a clear and intuitive idea to make it better. So let's just say we have csv.read. Why don't we have something called tsv.read, which was not there until recently? And it follows the Ruby's principle of least surprise. So to do this, we first have to see what are the different APIs, the API formats, and checking the API design. So we look for different patterns for making it more intuitive and the developer experience more smoother. So on this slide, if you look at the three examples, the top example is very verbose and very repetitive. But if you look at the bottom one, it's clean and elegant. You just have one line of code. But if you look at the second line, the second example, we have to read the entire file into the memory first, and then we parse it. And basically, that's like two steps where one should be enough. So the bottom example shows the power of good API design. It's self-explanatory, and it removes the cognitive load from developer. And this is how technically should be. So we look for the issue or the idea, because this was a problem that I faced myself, and I was trying to see if there's some other people who might have faced this, and there was. But a lot of Ruby community was just discussing maybe we can just have the column separator instead of having something new out of the box. So we tried contributing to Ruby with this basic idea. So we are going to look at our first contribution attempt. So the point here is the first contributions, especially to open source, especially to the core libraries, are rarely perfect. So that means even though, no matter how experienced you are, you have to go through an iterative process to get accepted into some sort of core library feature. So we have a PR, but we'll learn later why it got split and what are the different viewpoints of each of the PRs. So we made the PR, but the maintainer asked us to split it into two separate PRs. So this was where we learned about the best practices to follow in large code bases, especially core libraries, because we cannot just we cannot just commit something big, especially into core libraries, because it is going to have some breaking changes in the long run. And when we got this, the self-realization here was that we have to focus more on easier testing on specific functions instead of putting together everything together. And we have to focus on the independent releases for each of these features. And the split worked, which is a good approach overall. So we've been looking at the two PRs, one of which did not get merged or which got rejected, and the other which got merged. So this was the PR which got rejected. The problem here was that we were trying to check both the options here, and we were trying to raise an error to prevent ambiguity. So if we have only the colon separator, it is converted to the colon underscore separator, which only CSV understands. But it's not sort of the best principle for working with existing API structures. So we made a new PR where we were only focused on having the CSV bring everything from TSV. So it was like a CSV double colon TSV class. And the solution won. It was a very simple few lines of code where we were just using inheritance to leverage all of the existing CSV functionality. So what it means in simple words is we were just using the CSV library and we were developing something on top of it. So we were just overriding the initialize of the CSV class, and we were trying to set a default for CSV. So it's like we get all of the CSV methods for free, but we get tab as the default separator. So this is the beauty of object-oriented design or object-oriented programming, because we're trying to do maximum reuse and minimum duplication. So, and if you focus on the line with the default underscore options dot merge options, here we are trying to say if a user wants not CSV, not TSV, but if he wants something that he wants, let's say 4 tabs, or if they want something, anything out of the box, then they have the flexibility to define the default by themselves. So it's a very common, simpler example where we are not trying to remove power from users who need custom behavior. So when this pull request got merged, there were a couple of key insights that I could learn. We'll be going through them one by one. So one of the biggest was that Ruby's object model is incredibly powerful. By just using the inheritance, we can extend the behavior of the already existing classes. So there's a very less code change that we have to make. That means we make more maintainable and clear solutions. And the second one, in programming, we overthink solutions. We try to build some sort of custom implementations while the function already exists. So it's really important to see and use the power of the language itself. But when this happened, there was a bit of a thought process on the namespace consideration, because in Ruby, namespace hierarchy is a big deal, especially when we have a new class. So it might seem like a small detail, but when we try to contribute to core libraries, it has a significant long-term influence. So one of the reviewers, he mentioned here that the double colon TSV might be easy to use, but it might break the library's API, which means there was not so much of ecosystem stability in this thought process. But before we move ahead, we have, for the folks who don't know what is namespace convention, it's basically, we're just trying to group together. It's very simple words, everything together. So if it's like net double colon HTTP and net double colon FTP, you can see we have net common. That means we are trying to group the similar functionalities together. And if you look at the second example, it's like a different implementation, but we are still using the same primary concept of JSON. And if you look at the third one, we are using a more object-oriented way to handle the file names, which means we can use namespaces as they are. So when we were making the decision for namespaces, we have to think, should it be a global namespace or a namespaced, like more like local? Because the first one, it feels more convenient and it feels more like first class, like CSV itself. But it's a very risky approach for standard library because it's going to pollute the global namespace. And that means if you might have some gems or if you have some sort of Ruby feature, there's a very high chance it's going to conflict. So the chances of conflicts are really high. And if you look at the second one, this is generally safer and more organized because it has a relationship to CSV. That means it's not going to have breaking changes over the long run. So these were the sort of trade-offs that we had to consider while making the changes to core libraries. And it's sort of important to think from the viewpoint of namespaces. So now we can see the fruits of our labor. So we look at the present day scenario of how it's treated with the new solution. So you can look how clean this data is now. So even if we have the bacon, cheese, and liver, or if we have the, some other example of turkey, duck plus gravy, they are preserved as single fields, which means the data structure is clearer and it's cleaner and it's more readable. But more importantly, we do not have to specify a separator like we did before. So it looks like a simple thing, but having things like this makes a huge difference in real world usage. And after we implemented this feature, we wanted to write some tests and make sure if it works well, because no matter how elegant your solution is, it might need thorough testing. So we tried writing some tests. We don't have to go through all of it, but quickly going through it, we were checking in the beginning if the default separator is like a tab character, because that was the core functionality. And if you go a little down, we were trying to see if users can still override the default separator if needed, which means we wanted to give full flexibility to the users. And if you go a little bit down, the read TSV, we were trying to fulfill the main use case. We were trying to check if the actual parsing works with tab separated value. So this is just an example of how clear tests have to be to write a good design test. Of course, it's not perfect. Down the line, we might want to add more tests. What if the file name is wrong? Or what if the tab separated values are not 2 or 4 or something like that? So the point is, in the long run, we always have to keep making tests. And if you think the functionality is not working in a specific way, you can always write more tests and contribute back to the society. But coming back to the namespaces, let's take a look about why the colon SCP was rejected. We had a bit of discussion going on here. We don't have to go through all of this, but the core idea was we wanted to use the colon SCP instead of the colon COL underscore SCP. And there was a lot of discussion going on about it, but in the end, it's more like the API design. The Ruby core maintainers were not okay with having some sort of core changes in the API design. That means they wanted some internal consistency or some parameter naming patterns or something like that. So if we come back to our solution, it was only 3 lines of code, not so much of work, and there were small examples, small quantity of code. So it's more about the quality of the abstraction instead of the quantity. And here, it's sort of the end where we're trying to learn what was wrong over our code reviews. So in the beginning, we were trying to override all of the class methods. We were trying to define something by ourselves. We were trying to write more of the code which was already there, which means we had to understand more about Ruby's object model and the inheritance. So maybe I can take this a moment to go through the first PR that we submitted that was rejected, because here we were trying to duplicate a lot of functionalities which are already there. We were trying to redefine multiple class methods, or we were trying to, it's essentially duplicating the logic that was there. So it was a learning moment to not duplicate and use the Ruby's object-oriented behavior. And now we can see how the treats appear now. So we can see this is how it works in real life today. We can just use csv tsv.read a file. That means we don't have to specify the separator every single time. That's how we used to do before. And there's no more two-step process of reading than parsing. And we can naturally work with Ruby's powerful collection methods. And the most important thing is, as you see in the second line, we are trying to use the dot select. That means we can use all of the powerful Ruby frameworks and functions, even though it's a custom implementation. So all in all, it's an example of good abstraction. We just focus on the actual task instead of parsing the data formats. And now Oliver has his TSV files, so it's easy to share. This is just a quick go through of how it works now. So if you would like to read the files or write files, it's equally clean. As you look at the top, we have CSV :tsv of open, a file named W. So here we are using the exact same functionality of the CSV API, which was existing. And you can also see the treat names like bacon, cheese, and liver, or something like that. They are all preserved as a single field with the comma inside, because we're using tabs as separators. And the API symmetrical, we use the read for input and open for output. So it's the same pattern which exists for CSV. And this sort of consistency makes the API very intuitive to use. So that means everybody can share data like this without worrying about comma separation issues. And in the end, there were a couple of lessons I learned taking a step back and reflecting on what happened so far. So number one is the most important one. The best solution shouldn't be very complex or a clever one. The 3 lines code is quite simple compared to the a long abstraction. So the lesser the code, the better it is, in very simple words. We have to follow namespaces, especially when we're trying to create some new TSV class or some sort of new class. And we have to understand that if we make some sort of change in the core library, it's going to have a breaking change impact on the life of millions of developers. So we have to respect namespaces, how the global classes and global frameworks work, and the API designs. And in most cases, the contributors have to deal with maintainers who have been maintaining this library for a long while. So it's important to listen to feedback, especially as a new open source contributor. And testing is equally important as writing code. So we want to make sure that every aspect of our contribution is as we intend. Writing 5 or 10 test cases should work for the beginning. And as time passes, when we see in the long run, if the if we encounter any problems, it's always good to keep updating the tests, so it has the very long-term impact over the changes. Here we talk about how the standard library design is a bit different. So the impact of this was that the code finally got published in Ruby 3.3.1, which was a couple of months ago. It was a very simple solution, and I was not expecting it to get released, but it's a pure joy to see that such a simple code can have an impact on the life of so many developers. This was the CSV, the code release, and this was the class which was added. And it's time for everybody to join, contribute in any way they can for the Ruby ecosystem. Um, there are a couple of tips. The problem how I found this was through my own through my own code base, where we were using a separate function for parsing the tab separated values, and we had to use all of the CSVs. So I think it's always a good idea to look at pain points in your own code base. And if you think there's something that you can improvise, instead of writing a code or a function for yourself, you can always contribute it to the society, and it has a very long-term impact overall. And another good example is taking the existing issues. For Ruby, they have their own project management system. It's something called Redmine. You have to make an account, and you can have a look at the issues there. So this is also a good point to start. And you can also have the first time use or first time good labels to begin with. And if you're not technical, writing some sort of tests or documentation helps too. And this can also be true for, let's say you're using a class, and if you think the class does not work in the intended way, or if you see there's a loophole, or if you see there's a breaking change, you can always write a test and contribute back. So it does not have to be always something technical. And this is the most important step. Every Ruby project has its own contribution guides. So the library that I contributed to, the CSV file, the CSV repo has very different rules than the other Ruby files and repos. So it's important to understand each of the contribution guides. And thank you very much.